right, we're live. Welcome back, everyone, to AJC and the Web Devs. We got a new guest to the stream, with someone we all know very well, probably Glauber Costa, the founder of Turso, a distributed SQLite thing. I don't know if that's necessarily correct or not, but it's a SQLite database that is super cool. We had a great chat 3 years ago at Remix Conf. Welcome to the show. How you doing today?
Thank you. Remember you very well. It was a great time chatting. We were reminiscing on this before it started. Remix Conf was one of the time right before AI started, right? So we could still code like caveman. Great times. We actually wrote code by hand. Can you believe that?
I was, getting code out of the ChatGPT a little bit. I was just going into the chatgpt.com, like, write me some code.
Yeah, my first wow moment with AI actually was in the Claude web interface. Way before Claude Code. I mean, let me try this one thing, and then I pasted, and it works. It was great.
Yeah, my buddy and I built like a straight vanilla JavaScript little game because he was like, "What's the deal with this like AI stuff?" And I'm like, "Well, let me show you. Let's sit down. Let's build a game."
Yeah.
So, all right, we already got some people in the chat here.
All right, Shreya, it's nice to see you. Shreya has been a buddy of ours. He's always around. Great fan of Turso, and of course, I am a fan of everybody who's a fan of Turso. So he has my admiration.
Amazing. Awesome. So, we wanted to just get a little bit on your background. I think you have such a cool background, especially in open source. You did work on the Linux kernel. What was the first year that you, what year was it that you first started doing that?
It's fuzzy because it's like the fall of the Roman Empire. By the way, if you haven't thought about the Roman Empire up until this point, I ruined it for you.
Yeah, your daily
happens
dose.
with me every day. Daily dose of the Roman Empire. And nobody kind of knows when the Roman Empire fell. You just kind of put that date and say, hey, we're going to choose this. There's a clear before, there's a clear after, there's a fuzzy thing in the middle, and then you kind of pick something in that middle to be like the official date. So I was around the Linux kernel starting in 2003, 2004. Mm-hmm. So somewhere around that point, I could start calling myself, I suppose, a contributor. My first attempt to send code to the Linux kernel, probably around late 2003. I sent a patch to how we called back then. Today you call it a PR. Sent a patch to the ext2 file system, and a fairly old file system. And I thought that I had found a bug, and then I sent it, and as a response, I heard, "Bro, yeah, I don't. It's all good, man. Shreya was just 4 years old, so I was a lot older than
kid.
4. And then I send
13.
Yeah, I send the patch, and Alvaro, the maintainer of the VFS layer, the virtual file system layer, he responds that I somehow managed to introduce 2 new bugs in 2 lines of code, and that was unbelievable. And then people like me should never be allowed to get close to a keyboard again. So that was my introduction to Linux. I did not listen to him, although it wasn't necessarily pleasant. And around the end of 2004, I was contributing again. Still fairly, it's the nature of exponentials, right? Still fairly. I was pretty proud of the output, but compared to what came later, like a drop in nothing. But I made a couple of interesting contributions to the Zen hypervisor, and then I was hired by Red Hat, and then I think my career kind of started, because before that, I mean, it was more like an amateur kind of thing.
So the Red Hat thing that probably led on from the open source contribution.
Yeah. But the thing is that whatever I've done before, was nothing right after compared to what I've done after, because then I finally had time and people around me to help me and focus. I think the thing that changed the most for me, I mean, it's the same person with the same ability, and I had people around me. That's fine, but I also had access to people on IRC and mailing lists, so it's okay. And obviously, at Red Hat, I had a lot more direct access to more experienced people. But I think the thing that changed the most definitely was focus, because when I was just like in love with the Linux kernel, I was like looking around this massive code base, looking for stuff to do, and I didn't even know if the things that I was trying to do were worth doing or not. It was just like, what can I do to improve this thing that has millions of lines of code? Like, how do I even start? So again, the thing at Red Hat that I benefit the most was having focus, having somebody tell me, this is what we need to fix. Even though the focus was not that focus of when I joined Red Hat, it was right when I was fairly young. They were about to release Red Hat Enterprise Linux 5, and virtualization was going to be one of the key aspects of Red Hat Enterprise Linux 5. Everybody was busy. Nobody had the time for me. So they kind of said, go into the bug tracker. It was Bugzilla at the time. Just go into the bug tracker. Whatever you find, fix it. And if you don't find any, just if you find any other bug, open more bugs. So I mean, it's not like I had a fairly well-defined thing, but at least I had some focus. I had hey, there's this bug here that I can go and fix. Right? I know what the bug is. Somebody reported the bug. Again, reproducing bugs back then was very hard. You couldn't just ask Claude for directions. You have to go figure out like what to do. It would take days to reproduce one bug. But again, with that, and I started doing more and more, and then more complex projects after more complex projects, and then at that point it was no longer the Roman Empire. It was the Dark Ages. Like what came after it was the
Byzantium.
The beginning is a lot of processes as one big unit, and then you can isolate resources between those various C groups. And resources could be CPU time, it could be an amount of memory. And the particular problem that I was trying to solve was how to limit and track and limit the amount of kernel memory used for a C group. And again, because you can very trivially account the amount of memory that a C group use, because as your program allocates pages, you just counted this page here, this other page there. But there's a lot of things that you do that allocate kernel memory. Like, for example, if you open a file do a transversal on a file system, and that leaves a bunch of memory behind because you have all of those caches inside the Linux kernel. And at the time, nobody kind of knew how should we account for that thing. And if you don't account for that, you can kind of blow up the container, because you just go, like, you create a fork bomb, for example, and you start creating more and more processes, and each of those processes uses up a little bit of kernel memory, and then at some point the C group allocates all of the kernel memory, and then you think you have memory, but you don't. So the problems that we were trying to solve at the time was this: how to account and limit kernel memory. And again, it's very hard because kernel memory doesn't exist on behalf of any specific process. It's like kernel memory. And a lot of that memory usage came from file systems. So I worked very closely at the time with XFS, ext4, and the virtual file system infrastructure in general. So that's where I met Pekka. I didn't necessarily have any interest in databases. In fact, I had no interest in any computer program that was not the kernel. For me, the kernel was just the only thing that I really liked. There was always this joke, like, whatever people are talking about, that's just user space stuff. We don't care about that. It's just like who cares, right? But then I joined a startup in 2013. So again, around 10 years after the beginning of my period, not my period, you know what I mean, like the period in which I was in the Linux kernel. And that startup was created by two key people that created the KVM hypervisor. So it was very good. I am very good friends with them, although we don't chat that often anymore, just out of life and situations. But it was a startup in the OS world. They were trying to do something called unikernels, which at the time didn't work. Now with AI is getting a little bit of a revival. There's some companies doing unikernel extremely well, but we tried to do it back then. I think it was too early, and it didn't work. But then the company pivoted into writing a database, and I almost left because I said I have no interest in writing a database. But at the same time, I think I was kind of tired of working in the kernel, and I didn't want to go back, and there were not that many other things for me to do. And I decided to give it a chance and say, hey, let me at least see how this plays out. And I ended up liking it, and I liked it because in the kernel, you are fairly limited around what you can do, because the idea of the Linux kernel is that the Linux kernel, or any other operating system for that matter, can't really use a lot of CPU time, can't really use a lot of resources, because the kernel doesn't have an existence on its own, right? So you start the Linux kernel. What for? What do you do with this? I mean, there's no point in starting the Linux kernel. You start the Linux kernel to run something. So, the kernel exists to give other processes a interface. So every time you go into the kernel, the goal is to get out of it as soon as possible. I mean, you go into the kernel because somebody called the kernel to do something. So you want to get out of the way and just go back as soon as possible. So the algorithms, they tend to be a lot simpler. For example, I don't recall ever seeing any recursive algorithm ever in the Linux kernel, just because, again, it can blow up your stack quite easily. And everything is very simple. I mean, it's the kind of stuff I like because it's very physical. That's what I like about computers. I mean, again, unsurprisingly, I totally suck at front-end development. I can't center a div, although these days I probably can. And none of that. So I always like to be very, very close to the systems. And databases are like that. I mean, databases, as far as applications go, they're probably one of the closest things you can get to the machine. Yeah, but because they are something that has a goal and has a reason to exist by itself, the algorithms get a lot more complex. I mean, you have a lot more things that you can do. And then I ended up falling in love with it. And that's how, and then I stayed in this database company for almost another decade. Database company was called Scylla, for those of you who are in the know. It's a NoSQL database in the petabyte scale workloads. And that's how I got acquainted with databases. The folks at Scylla were almost all former Linux kernels, so we would patch the Linux kernel all the time. Like, when we found the bug, turns out the issue is in the kernel, and then we're going to go investigate and find out. And it's a very interesting thing because, I mean, we really kept it very low level. Turso is nothing like that. I mean, Turso, I don't think I ever touched the kernel working on Turso.
Yeah, Scylla was one of those projects that I'd always hear about on Software Engineering Daily. I don't know if you knew that podcast back in the day. Jeff, the late great Jeff, he would bring on these database people to talk about stuff like that. And I was totally new to the industry, and I would listen to it, and I would just be like, wow, this sounds so interesting, and I have no idea what they're talking about.
In the beginning, neither did I. As I said, I almost left the company, and I'm happy I didn't. But because I truly had no prior experience or interest in databases, but it grew on me, and today I suppose I do.
So that fed into Turso. Then, did you go from Scylla to Turso? Was there anything in between?
No, there was something in between. Yeah. What's up, Dev?
Yeah, Chisel Strike. I remember that.
That's Turso. No, that's okay. Turso, because it's the same
Turso,
company,
yeah.
right? It's the same way. Scylla didn't start as Scylla. That was a pivot, and Chisel Strike was Chisel. I actually can't explain Chisel Strike today. That back then was one of the hardest things for us. Was like, how do I even explain what this thing does and what this thing is? Today I can, and I'll tell you later. But the thing that I had in the middle was Datadog, because the thing is that when I was ready to leave Scylla, I always wanted to start a company. And I always wanted to start a company with Pekka, because there was this day that we were all working on our Slack channel. Slack already existed back at that point. And I was always dunking on Pekka. Like everything Pekka would say, I say, "You're so stupid, Pekka." And then the founder of Scylla scolded me, saying, "You can't say those things because Pekka might get offended." And then I said, "But Pekka doesn't get offended, and he's my friend. That's just how he does. That's just how we do." And then he got truly mad at me, and I remember at the time he was like, "Oh, but it's unprofessional, and other people see this, and at that moment I realized that if I wanted to spend my life dunking on Pekka, I would have to start my own company. And I also realized at the same time, because of the power imbalance, that he couldn't be my employee. Because then, right, so he had to be my co-founder, and that's how I decided to found the company. But at the end of my tenure, that was in 2020. So 2020 was the year that I just could not keep going with Scylla for a variety of reasons. One of them is just I thought I was just doing this for too long. I wasn't really aligned with strategic direction of the company. So I figured, hey, I should maybe now's the time. But you might remember that 2020 was a very rough year.
I feel like it's a transition year for so many people. It's like there's because things are changing so much in the world, it was almost like it kind of compelled a lot of people to make some big changes, like it did with me, like kind of in some way coincidentally, but still, it was kind of in the air.
Yeah, and the thing is that, again, maybe it was again, I don't know if this is PG-13 or R.
You can say whatever you want.
But perhaps I was a little bit of a pussy back then. But I wanted to do it, and I think I was ready for the change. But it didn't feel there was so much already changing in my life. I mean, because I just had a kid, COVID started, right, and then I decided to move to a different city because I was living in Toronto at the time.
You went to Austin, right?
No. I moved to London, Ontario, a small town in Canada, 2 hours away from Toronto. Because the problem was, like, both my wife and I working from home with the baby crying all the time in a shoebox apartment, because Toronto real estate is quite expensive. So I just can't do this anymore. I have to get out of here. And then, like, I bought a house in this new town. I didn't really know anybody there, and I had just bought a house. I mean, it just didn't feel like starting a company at the time was the smartest idea. Also, I knew nothing about venture. Today, I still don't, but I think I don't know a little bit more than I used to back then. And for me, it was like, I want to start a company, but I knew nothing about startups, or nothing. And turns out 2020 was actually a pretty easy year to raise money. But I did not know. So for me, it was all like, I don't want to take the risk, and I don't even know where to start, and it feels like a very stupid idea. So then I joined Datadog. But after a year at Datadog, then it wasn't 2020. COVID was still there, but it became a part of life. It became a little bit of a non-factor. And then Datadog, Pekka started interviewing at Datadog. And then I said, "Oh, man, fuck this shit. Let's just start a company together. I'm not doing this again. So I'm not working with you again." And then we started, and then we decided to start the company.
Where were you in 2020, Dev? What were you doing?
2020, I think that was the first time I was starting to React. No, it was my third year, or I think it was my third year of college. I just started at a contracting firm. That was my first project. I was migrating a huge Angular 1 app to React. That's what I was doing. And then everything went remote, and the world kind of ended almost.
Yeah.
I don't know. For me, the world got better because I got to stay at home for the whole time.
Yeah. So I stay over a little bit over a year, Datadog, and then we founded what was called at the time Chisel Strike. So now for Dev, because Dev, that's around the time I met Dev. Chisel Strike was convex for SQLite. That's what it was. But nobody understood what that was. And convex wasn't doing great either at the time. And everybody who came to try it, I mean, we did create like a quite respectable for that day standards Discord community, and people came chat about it. There was some interest. I mean, we got to like 1,000 GitHub stars. So I mean, there was some level of it wasn't like zero. But everybody who came to our community came because of SQLite, because they saw this as a easier and more powerful way to deploy SQLite. So they were always asking us about SQLite. Nobody seemed to care about all the API things that we were doing. It was almost like something that stood in the way. Again, we kind of became a little bit jaded with, we can't explain this thing to anybody. And it seems like Convex has more money, and they're more, because they raised a big Series A at the time from Andreessen. Because they were doing things like that before. I mean, Convex evolved from something that James was already doing. And Chisel Strike for us was just, we were not doing it. I mean, we had the idea and we said, hey, there is a place for this, but we didn't have anywhere close to the level of experience and commitment to that they had. And then it just felt to us like it's pointless to keep insisting on this, because I don't think we have, and this is something very important in startups. Yeah, Pocketbase was around the same time as well. You truly need, I mean, and I don't think I understood that before. I understand now. You truly need a unbelievable amount of conviction to do a startup like this, because you're gonna go through periods in which everybody thinks you're crazy, and things take time to catch on. And then as we looked at ourselves, we did not have that conviction, right? That the Convex had, and we thought that they were doing it better anyway. They had more structure, more everything, and they said, why insist? And the stuff that people seem to like about what we're doing is you can distill it down to SQLite, and in SQLite we actually have that amount of conviction. So for us, it was like if we remove the parts that we don't have the conviction around and are just there because it's us playing and seeing where things go, right? And is there anything in this? Because again, if it isn't, then we're going to go do something else completely different. But if there is, then we can perhaps save some of it, which we didn't really save any code or anything like that. But we found out that we did have the very strong conviction that there was something around SQLite that we wanted to do. Because again, the reason we did let's call it like Convex for SQLite, is that we truly like SQLite. We love the idea of like, hey, there's this super small database, it can go anywhere, and then our goal is like, how do we turn this into like a deployable database and bring the good things about this to people. And again, after some soul searching, we found out that we had the necessary conviction to eat whatever shit the world threw at us, but it had to be only on that box. We did not have the conviction on the extended vision, and then we got rid of it. And that's how we renamed the company, and so on and so forth.
I don't know if I've ever asked this before. Why Turso, that name?
Why the name? Because Becca is Finnish. And apparently there is a character in Finnish mythology called Turso, the stupid way he says it, Turso. And then one day, apparently this is famous enough in Finland that there are all sorts of beer brands and submarines with that name. One day he was having a Turso IPA, and he named the repository because we had this experiment, like let's try to launch something, right? And then he had this experiment. He was drinking the IPA and named it Turso, and we all kind of liked it. but the thing is that Turso is just Iku sounds Japanese and it's very simple, and so we're going to have all sorts of problems getting domains for this. But I liked it because it was short. But at the same time, I mean, the disadvantage of it being short is that domains are going to be a big problem. And again, it sounds very Japanese, and nothing wrong with that, but that's just not. I happen to love Japan, but that's not where we were coming from. And then Turso sounded like a cool, powerful name. Just it's short enough. And
you got
it's
Turso.tech is your domain now, which is
because there's an accountant in Florida that owns Turso.com, and we tried to buy from them, but we couldn't. So whatever, doesn't truly matter.
That's super interesting. I love hearing about where names come from. I'm glad I asked that. That's really, really cool.
Yeah.
Cool. So
I remember you telling me that story at some point. I think we met at the first time we met was one of the conferences in Salt Lake City. It was not RemixConf because I did not go to the RemixConf.
I don't remember.
It was Kent's conference, the one that Kenzie Dodds hosted. Might have been that one.
Epic conference.
Epic Conf, yes. Yeah. I think it was probably that one.
It.
Yeah. But I think that's a really fun story. I think the part about Turso that I think got caught a lot of attention from the community was your focus on Rust. Like way before the SQLite Rust rewrite, the entire infrastructure of Turso was built around Rust. And I remember the Primogen being super excited about that and telling a bunch of people. I think he even went to Vercel, and when they launched their database product, and or at least when they partnered with Neon, and Primogen was in their faces like, Neon is the wrong choice, should be going with Turso.
Turso was a very different thing than it is today, though, and lots of lessons there. And one of the lessons, I don't know. I don't know how much you want to go because we want to talk into reliability there. But
you can totally dive into wherever you want to go. Don't worry.
One of the lessons, again, it feels like so very obvious because that's the thing. That's the things that people talk about startups all the time anyway. But my favorite movie, The Matrix, right? There's a difference between.
Hey, that's my favorite movie. My man.
Right?
Yes,
one,
absolutely. Yeah, of course.
Not the fifth or sixth or however.
I haven't even seen the fourth. It's just going to disappoint me.
You shouldn't, by the way. Although I have this theory that they made it bad on purpose. But
yes,
that's going to be you know what I'm coming from.
I align with that.
They have all those internal references about how the studio made us do it in the middle of the movie. So for me, it felt a little bit like they probably had to do it, but then they inserted the jokes that they had to do it in the movie because The Matrix 4 has this meta narrative, and go watch it or not. Again, if you don't,
it's a fun watch.
It's not really. I mean, it's super terrible, man. Anyhow, if you're one day bored and want to watch it, but then there's a difference between knowing the path and walking the path, right? And to be clear, we regret nothing because everything is alert. Something good came out of everything, all the things we did. But at the time, we looked at SQLite and said, we just love this thing, but this sounds ripe for a rewrite. We should rewrite it. And we decided not to do it. And again, I want to be very fair to the path that took us where we are, because I think if we had rewritten SQLite back then, it would have turned out very differently, and perhaps it would not have succeeded to the level that we did. Perhaps the company wouldn't be here. So I want to be fair to the path we took. But we're here sharing stories. We wanted to do it. Like our desire was to do it, and the reason we didn't do it can boil down. I mean, I can explain the proximal
Just
things,
real quick,
but
just so I understand, you're saying you wanted to do it, then decided not to, but then did you decide to do it later? Because I thought
much
you did
later,
end
yeah.
up
Turso
rewriting it.
today, So today we have this rewrite of SQLite from scratch.
Okay, great. Yeah,
But
so I'd
that
love to
came a
hear
lot
like
later.
that journey of how that came about. Yeah, that's really interesting to me. Yeah.
So we decided to do it. We wanted to do it, but when we looked, and again, the thing is that startups are all about taking the crazy big swings.
Yep.
So from the perspective of taking the crazy big swings, we should have done it, right? Because that is the crazy big swing. You get SQLite and rewrite it. But yeah, I'll talk about it. But what Shreyas is asking, but what we decided to do instead was fork it. And again, it's not that we necessarily thought that forking was a bad idea. We figure we can build something cool with this. But for us, it was a compromise, because for us, what we wanted to do was rewrite it. And the reason we didn't do it boils down to fear, right? We're not going to have time. It's going to take too long, and we ended up raising a lot of money. Well, not a lot. Like, for example, Convex raised a lot more, but we raised a pretty decent seed with Chisel Strike. We did spend a year with Chisel Strike. It didn't go anywhere, but because it was getting like early signs of traction, we hired a bunch of people. And what we thought is like, hey, with the burn that we have that many months to do this, and there's no way this will work. And again, I remember after the boom, like in 2021, 2022, there was like a big bust. So we looked, interest rates went through the roof. So the market was in complete disarray. And again, in hindsight, I should have cared about none of that. I should have decided this is what we want to do. This is what we believe should be done. Now let's go find a way and do it. But then again, I wasn't that person back then, so we wouldn't have done it well. But then we decided that there is a plan here that works. And the plan that works is that we fork SQLite, and then we create a product based on that in months. And that's how Turso was born. So Turso was born as again, this cloud offering based on a fork of SQLite that we call it libsql. And we call it libsql because, first of all, the fork came first. First, we forked it, and then we said, now that we forked it, let's think about how do we monetize it. And we want to go monetize this in months, like 1-2 months. And then we called it, the cloud service was called Turso, right? So that's the thing. And then the fork of SQLite was called libsql. And what happened with that is that, again, we had this desire that people would use libsql instead of SQLite, and then they would deploy this to Turso, which was was exclusively the cloud product. And again, the first problem with that is that the naming got really confusing. Like, people didn't necessarily know. Some people heard of libsql, but they did not know it was even created by Turso. So there was a lot of confusion there. And second, our cloud did pretty well. So our cloud was growing, and we were growing at a good pace. Again, wouldn't be called a good pace today, but it was a good pace back then. But nobody was using libsql, right, as a replacement for SQLite, and this was a little bit sad for us, because we part of the reason why we wanted to do this is that, hey, we want to replace SQLite, and we think there is a better, again, nothing wrong with, we do love SQLite, but in the same verge as Scylla was a reimplementation of something else as well. We figure like we can do better, but nobody used it as a purely local database. When people would come to the Turso Cloud as a way to deploy SQLite, and then like things in the fork were technically responsible for what we could do in the cloud, like the wall virtualization thing that we did. There were many things that our cloud wouldn't be able to run without. But at the end of the day, that this was still SQLite, and people would use SQLite locally, and then like, and nobody was using libsql for a use case that didn't involve. They could even perhaps even use it as a staging area to the cloud, right? Those were all the use cases, and then what happened is that at some point, I mean, we kept asking ourselves why didn't we go rewrite this, and you know, there's always something. We started seeing our cloud grow, but as we were kind of cornered in a place of the market that we didn't like, and because a lot of people saw Turso at the time, and I actually heard that from okay, if it makes you feel any good, I still have many libsql instances from that time still in production today, and I hope you have it for a long time. We're not going to deprecate it, by the way. We truly believe in doing this, and like you running a production, we should disrupt you as little as possible. Sometimes there are no choices, but it is what it is. But the thing, like, even one day, I don't remember which I think it was an Amplify conference. I met Theo, and Theo was telling me that he was recommending Turso to a lot of people, which should have made me happy. But then as he kept telling me why, it was because I think Turso is a great place for you to have your initial projects, right? And I'm sure he meant no harm. On the contrary, I think I'm sure, you know, he wanted me to be happy about it. But that's just not what I wanted to do. And just like I don't want to create a database that is a toy just for people to get started. The database for people to do simple things. That's not what we wanted to do. And there's more than that. It's also a terrible way to build a company because you're trapped in a very low value place.
Yeah, people use you because you're cheap and then they plan on migrating off.
Yeah, you're always going to be the second option. I mean, you're always like, you know, this is what I truly want, but then I'm going to go use this other thing. Right? So it's very hard to command pricing. Our ACV was just terrible. I mean, and it was funny because like if you were looking at the metrics, everything was going well. But as we projected this into the future, like how do we get out of this? And we didn't see a way out. And Shrey is just saying like the neon of SQLite, but the problem is that there is a gigantic market for Postgres, and there isn't a gigantic market for SQLite, right? And what we were trying to do with Turso, which again, at the time, a lot of people did criticize us for it and said that we had no idea what we were talking about and blah, 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 because that's not the strength of SQLite. But our vision from the start, remember, even with Chisel Strike, is like transform SQLite into a deployable, like real life database. So this thing that people came up with is just like, oh, you guys don't understand the power of SQLite. What SQLite is really good at is the device and etc. But like we had no interest in doing this. That's just not what that was not our thesis. That was not our passion. Like we wanted to transform SQLite into a real database, so to speak. And this was not happening with the fork of SQLite. And it wasn't happening because making extreme deep changes to the fork was very hard. And it was very hard for a variety of reasons. It's very hard because SQLite wasn't designed to be changed, in the sense that, I mean, and once more, nothing wrong with that. I respect SQLite deeply, but SQLite is a one-man show, essentially, right? There are more people who contribute to that, but it's essentially Richard Hipp and some others. There's no large community around it. And again, even the core devs, I think they're 2 or 3 in number. So it's not an architecture that is very modular, and you know, things are not very well, not a lot of separation of concerns. So every kind of change that you make, you're potentially changing everything. It's also written in C, which means that one mistake in the outer layer of the database corrupts memory that is used by the B tree, and then you corrupt the data, and there you go. So and the legendary SQLite test suite, which should help us do this, because SQLite has this legendary test suite, and I think now we're getting closer to the topic that inspired your invitation, is proprietary. So we just couldn't, we would make changes, but we couldn't really test the changes. We don't hate C. All my career was done writing C, but it's just not what I would reach out today for anything. It had its time, and I think knowing C, it's very all the ABIs, everything is still very, very C based. I think understanding C is crucial for you to understand how systems work. But it had its time. It's very hard to work safely with C. And again, I know because I wrote my share of memory corruption bugs, and I debugged my share of memory corruption bugs, and it's truly hard, right? So
no jokes allowed on this podcast. What are you talking about? We don't.
Dude, the thing is that tomorrow is on the news. Turso hates C, and have you seen Twitter?
I want to dial back real quick. You're talking about the proprietary test suite. That's really interesting to me, because I know this is a thing that has started to happen more now, like the AI age, because people are worried about people porting their product, and they think the test suite is kind of like a really important part of that. But it sounds like this was something that probably predated AI.
Yeah, predated AI. SQLite always done this way.
It's really interesting.
Yeah, although it is funny that there have been some recent changes where open source projects make their test suites proprietary because they're scared of people with AI agents, fleets of AI agents rewriting their entire project somehow.
Yeah. And I have no idea what was their motivation to do it. Perhaps it was something similar, because SQLite is a relatively simple project, right? So just again, it is not really, but in comparison, it is. So perhaps they had this fear that some I truly don't know, but it is how it is. It's proprietary. So again, making deep changes, and you're always having to rebase your changes all the time, because as SQLite releases new versions, you have to rebase your changes on top of that. And then again, so at the end of the day, our changes were not incredibly intrusive. And we knew the things that we needed to do to turn Turso, right, libsql, however you call it, into a really good database. But we just couldn't do it. Like we felt that our hands were tied. And then what happened is that one day we kind of decided, and the full sequence of events is that Pekka started experimenting with a rewrite and say, how would that look like? And the first version of this rewrite was 90% the simulator code, 10% database code. Then we're going to, very soon, we get into the meat of it, but 90% the simulator code, 10% the database code. The database code could only do a select query, but without filters. So you could just select an entire table, and you couldn't write to it. So it looked very basic, right? It's truly just a proof of concept. And again, 90% simulator code. All he wanted to answer to himself is like, I have this, if we were to rewrite SQLite, I think it should be done with this architecture, this way. Would that work? And he did it on his GitHub. Turso never talked about it. I told him that Turso would never talk about it. So like, you want to do it, fine. I told him, like, at first, don't do it. And again, don't do it because of the distraction, right? Hey, there's the product. But he decided to do it anyway, and he put this on his GitHub account. And people would find it and share with others, and it got you almost more than 1,000 GitHub stars on its own.
Is this Limbo that you're talking about?
This is called, and he named the project Limbo, right?
Great.
And so what happened is that we hired 2 people from this community because they were truly good. So think about it. There's this rewrite of SQLite on this dude's GitHub account, right? And top-notch people that were working at Red Hat at the time. Was one of our first hires, like on the Gluster Fest thing. He was working on Ceph, I think. Super high-level people start coming and contributing to it, to the point that we hire 2 of them to go work on Turso, which was then a cloud service. And then that's when we realized, you know what? Perhaps we should just openly talk about it, and we don't have the resources now to do this. It's crazy, and again, we are fighting for our lives in the company, because again, the company was growing, but almost all the other database companies were growing a lot faster, and you know, we still have to focus very deeply into what we're doing, so we don't have time to do this. But perhaps if Turso talks about it, it can serve as a future reference for what we're doing. The community can grow a little bit more. Maybe this catches on as an open source project on its own. And worst case scenario, this serves as a recruiting honeypot, right? Because good people are coming to this. So let's just talk about it. We also had a slow month in December. We didn't really have a lot that we released to talk about in December. So then that serves as a goodbye message to the year. And then we posted this thing in December 2024, the 16th of December 2024. We post this, and I disappear to go celebrate the birth of our Lord. When I come back, this thing had 9,000 GitHub stars. It was blowing up. 64 contributors. This guy from Snowflake started contributing to it. Like, this other dude that was in prison starts contributing to it. And I was like, how the fuck can you even do this? Like, do you have internet in prison? And this is Preston, of course, who is today a free man, lived in San Francisco. And I was mesmerized with the amount of attention that this got. Like, it truly seemed that our thesis that the world wants a better version of SQLite was fundamentally right. We just didn't quite get there, right? And then we had this choice ahead of us. Becca and I were like, look, man, we wanted to do this a long time ago. The reason we didn't do it is because we thought that we had no money, no runway, not enough runway. The company's too big, and and now we announced this rewrite of SQLite, which is experimental, and we say it in the post, by the way. If you read the post, that like, we don't know what we want to do with this. I mean, this is perhaps we were very honest. We're very honest people. Like, we have no idea where this is going to go. Don't come asking for more of this. Like, we may or may not work on this, and we might put some couple of people in the coming years. And the interest was tremendous. And then we said, look, why wouldn't we do this? And the reasons we wouldn't do this is because we have no time, we have no runway, we have no money, just the same reasons as before, right? And it feels to me that we're given a opportunity to, like, we regret not having the courage to do this before. And now we are given the opportunity to do the same thing. And but the irony is that the circumstances are exactly the same. All the reasons that we would have not to do this are the same, right? And so, are we doing this or not? And then at that point, we decided that we had to do this, but we had to do this very carefully. So we said, look, we are going to do this, and now we're going to find the way to do it. And unlike Jesus Strike, Turso was a real company, and we had real users, and we care deeply about our users. And more than that, that's the company that we wanted to build. I mean, well, the thing that we always wanted to build, like SQLite as a real database, and in our mind is like, look, we can't really pull the plug on this product, because that's it. I mean, nobody's going to trust us ever again. Neither should they. It makes no sense to take a product out of the market just to bring the same product based on a different engine a couple years later, it will completely flop. So we have to keep our cloud, but we can't keep the investment on it. So what we decided to do was that we fire half the company. And again, we reached this decision in 2 days, because for Pekka and I, it's like, look, man, if we don't do this now, like, we'll never forgive ourselves, right? This is what we always wanted to do. We didn't have the courage to do the first time. We are given the chance with the same circumstances. How do we make this happen? And first thing, we need to buy ourselves time because we understood that like the company will be very weird for investors, for anybody in the meantime. Our revenue wouldn't grow. I was actually very pleased that it didn't decrease either. It showed me already a first hint that Turso was a really good product, right? Because I imagined that once we announced to our community that, hey, we're going to go put all of our efforts into rewriting SQLite, I expected a lot of people would just bail, and it did not happen. So, that was the first thing that got us very happy. Hey, turns out we have a truly good product here. Because sometimes it's hard to appreciate how good your things are because you see all the problems and whatnot. But then we wrote this blog post. We were writing SQLite and we're going all in. That was, fast follow to the Limbo post that they put on stream, essentially saying we need to do this. We're going all in. It's clear that the world is a better SQLite, and we are the ones that need to do it. It has to be us. It's this thing about, people want it, people are clamoring for it, and we can't not do it anymore. But unfortunately, to do this, again, we're going to have to decrease the investments to the Turso Cloud substantially. The Turso Cloud is, and by the way, I'm saying Turso Cloud because at that point we said this is also an opportunity for us to get rid of the confusion in names. So we decided to, and Limbo was just a code name anyway. So at that point, we decided to call the rewrite of SQLite Turso, and then the Turso Cloud, and then the cloud became the Turso Cloud. And that actually made things more confusing because now we had Limbo, LibSQL, Turso, and Turso Cloud. Yeah. But we thought we can live with that because this is temporary confusion, because once Turso is ready, then there's no more confusion. And so we decided that we were okay with that confusion. And we would just explain to people, and people would say, well, "I didn't understand any of that. You guys crazy?" As I said, perhaps. But it was a confusion that seemed to us temporary, so we decided to just bite it. But we also didn't want to rename Turso Limbo to Turso right away. We said this doesn't work, and this will harm the brand. So we figured when we release our first alpha, at that point we're going to rename it to Turso, which is what we did. And now you had a rewrite of SQLite, and that took almost all of our engineer resources. Just got an email from Glauber about concurrent writes. Is this recording or not live? Oh no, it's because I'm using resend, and this is live. But the way it works is that you fire the newsletter, and we have like 300,000 people, so they don't send out 300,000 emails at once. The newsletter is sent over. It might even take many days to send all of them.
Yeah, I also
just safe for another day.
Yeah.
Yeah, I also just received the newsletter. Here's my cheers for SQLite Busy. I'll never miss you.
There you go. Yeah, there you go.
I said
but that's just because it's going to be sent. I mean, my Turso accounts received it right after I sent it, but some people are going to receive it tomorrow. It's just the way because they have to send it slowly. Email kind of sucks, man. Like email kind of sucks. I mean, the infrastructure, like, why can't you just send 300,000 emails in 5 minutes? Like you should. Right? It's just the way the whole thing is designed at the infrastructure level. There's nothing to do with the senders. It's truly like the email infrastructure and the clients. But anyway, that's not a problem that I'm in the position to solve. And so as I was saying, like, and at the point we said, hey, we're gonna go all in on rewriting this. Once we release the first alpha, we're gonna rename this to Turso, and then we're just gonna have this database that is like SQLite but better and gets deployed to the cloud. That's it. But people kept accusing us, because that's what the internet does best, right?
Something about database too. Database people get really riled up. I've noticed.
I don't, man. I try to be the chillest person.
Yeah, you're the chill database CEO. That was one thing I actually wanted to talk about at some point, is why database CEOs are so aggro.
Yeah, because no one else thinks about the Roman Empire.
Yeah, I don't know, and I can't speak for them, but I truly don't like it. I think it's just it's very sad that people fight that much. And anyway, that actually makes me so sad that I don't want to talk about it. But the accusation, I mean, the wildest accusation that I received, that I'll never forget, in the process of rewriting SQLite, is that I was trying to erase Jesus.
What?
I don't know.
Fair, there was someone who was Orthodox who was really mad because you're a Catholic.
It's I can't even understand why. My best guess is because that, you know, SQLite had the code of conduct and at the time I was speaking, not criticizing, but just saying we don't do it like this, and this is why we don't do it like this, and we believe a technical community should have a technical direction. But they do whatever they want. And in fact, I said in the tweet, live your life like that, you're gonna have a great life. But it's just not how we believe a community should be oriented, right? Because it's just not the way. And then at that point, I was accused of trying to erase Jesus and etc. And I was like, what are you talking about, man? But it's funny. The internet is a funny place, man. It's so funny.
Yeah. So we got someone in the chat here, bringing us to our topic that we're going to talk about anyway. PG. Yeah, let's talk about PG Micro. What is PG Micro?
Yeah. So PG Micro was my turn to do what Pekka did, and let me just talk about the accusation first, because the one that I was getting to is that the other more technical accusation that we received is that we had no idea why people liked SQLite. It was not about the features, and it was all because SQLite was very reliable and battle tested, and SQLite never breaks, and SQLite is perfect. And by rewriting SQLite, we were obviously making it worse, because you would have to write 10 years of tests to get to the level of reliability that SQLite has. Therefore, we would fail. And then this other person said that he never had any other company that he rooted more for the company to fail. Super fun. It's always spikes my cortisol to hear it. But we kind of did. It was not Lunda, but we kind of did understand that pretty well, because again, what those people were missing is that we were very, very well aware of the fact that reliability was the linchpin of SQLite, and the reliability was the thing that people liked the most about SQLite. Because guess what? Reliability was the thing that we liked the most about SQLite. And when we decided, and in fact, this is exactly when I said in the beginning, for those of you who are joining now, it might have been for the best that we didn't rewrite SQLite right away, because we learned so much in this period. And one of the reasons we didn't start with the rewrite of SQLite was exactly this: is that we can't really. I mean, it's going to be truly hard to meet the reliability standards of SQLite. But when Pekka came up with this experiment that became the Limbo project, that later became Turso, that was exactly what he was trying to do. So can we do it? I mean, is there a way to write the software that would lead to that level of reliability, if not more, without paying the penalty or the capital investment of writing tests for 10 years and right, because the SQLite test suite is reported or rumored to have 10 times more lines of code than SQLite itself. It's truly like a lot of work. And we wrote it with deterministic simulation testing in mind. And deterministic simulation testing is truly interesting because it's really hard to plug into existing systems. And so you kind of have to write your system with that in mind. Because, for example, for deterministic simulation testing, at the end of the day, is just a way for you to generate tests automatically. So what you do is that instead of writing tests, like imagine a unit test. Unit test encodes the behavior of the output. What is the output given at 3 to 6 times, not 10. Don't trust my numbers. First of all, for me, it's a rumor. So and second, I'm terrible with exact quantities. So if HIP says 3 to 6, of course he's right. But deterministic simulation testing, when you write unit tests, you encode. Those are the inputs. Those are the outputs that I expect out of those inputs, and then you run it. But the problem is, what is the output that you expect out of all the other possible inputs? And there's so many more possible inputs that you could put in your tests. So what deterministic simulation testing does is that the first step, and I'm simplifying this quite a bit, but the first thing that you do is that when you're writing tests, you don't write unit tests anymore. And again, it's not that you never write unit tests, because we test by layer, so we do have unit tests, but you encode properties of the system, right? So examples of a property: if you at the end of a battery of writes or mutations, let's call them mutations, writes, deletes, updates, at the end of a sequence of mutations, if you run a integrity test in the database, the integrity test has to pass. So what you are encoding with this property is that you're not going to corrupt the database, right? And it's funny because in the beginning, because we didn't trust our code for integrity test, we would run SQLite's integrity test, right? Because the file format is the same. And so we would just, you close we can't do this anymore all the time today because we have features the SQLite doesn't support, but now we trust. But the scaffolding of this is that run a sequence of things and then run the integrity test with SQLite. And if the integrity test doesn't pass, that means that a property was violated. Other examples of properties are things like if you query something using an index versus not using an index, you have to have the same response, right? Because if you have an index or you don't have an index and the query differs, one of them is wrong. Now, you might not know which, but the one of them is wrong. Or if you write if the database committed a write, and if you read that after, you have to write what the database was committed. So the ASIC properties. So you essentially encode properties, and then instead of writing tests, you write test generators, right? That it fuzz the space of possibilities. And at this point, this could be just like fuzzing plus property testing. But then the cool part of that is that you replace every single operation that happens in the database that could have a non-deterministic behavior with a deterministic version of it.
Yeah, I'm gonna just hop in here real quick because I'm a total noob to this stuff. So This was the Google AI overview that it gave, and you can let me know whether this makes any sense or not. Deterministic simulation testing is a software testing method that runs code inside a fully controlled simulated environment by controlling non-deterministic variables like clocks, randomness, and thread scheduling using random seeds for exact reproducibility and pairing with fault injection.
Yeah. So, for example, our simulator doesn't use threads because every time you use threads, you may have scheduling issues like this thread in this
Box
one
or
run.
syscall?
It pretty much. I mean, it did, at some level is the way it works in Turso is that you have every I/O goes through a virtualized I/O, and then when the I/O runs for real, it runs against the system. But when the I/O runs in the simulator replaces that I/O with the simulator's view of the I/O of the system. And it's pretty hard to use dependencies because you can use a dependency that itself calls a thread. So we don't have a no dependency policy, but we do have to scan the dependencies that we use and be very careful with them and audit what they're doing. For example, it's enough for the dependency to take a clock measure for the system to become non-deterministic already, right? Because if you read a clock through the I/O interface, if you don't, now your system is deterministic. So we have to be very careful with the dependencies that we pull. We do pull some, we trust. And then you write a simulator. So I mean, we don't have like 3 to 6 times more lines of code than Turso, but we do have the simulator. And what the simulator will try to do, no, we do use the standard library, but again, there's allocations are deterministic in a way from the point of view of this, but it's we do fault injection. So we do fault injection in which we simulate out of memory conditions, but you can just replace the allocator to do this. You don't have to have a policy, and you don't use the Rust standard library. So Turso runs in the simulator, and then we're always like creating new tests randomly, and that's the beauty of it. When a test fails, then you have, because everything is deterministic, the system is behaving as if, hey, what time is it? And give me a timestamp, and you get a timestamp. But if you run the simulator with the same seed again, that timestamp will 100% of the time always be the exact same. All interleaving of all events will always be the exact same. And then what happens is that if you find a bug, it is very easy to reproduce the bug. So deterministic simulation testing is a double whammy because first of all, it finds all the freaking bugs. And second, and again, it's not magic, so there are some bugs that it doesn't find, but then in our experience, the reason it doesn't find the bug is that the space of possibilities wasn't explored enough, and then you make a tweak to the simulator, then now it is. And like, for example, we had 2 interesting scenarios in which we didn't find classes of bugs. One of them is that it was very simple. The simulator just wasn't creating indexes. So bugs related to indexes were not caught, and then we just taught the simulator to also create indexes randomly, right? And now we found a bunch of other bugs. And the one that was amusing the most, and that's actually interesting because that one led us to rethink our testing strategy and evolve our testing strategy to be what it is today. There was a bug that only happened in databases that were larger than a gigabyte. And we wrote a blog post about it. I'm not going to go into details about it. It was a very fun discovery. And every time the database crossed the gigabyte, if you will run the Turso integrity check, it will pass. If you run the SQLite integrity check, it will fail. And we had no idea why. We spent a couple of days trying to figure out why. And then when we looked at the database, we could query just fine. The data was all there. I mean, it didn't look corrupted. But SQLite would report it as corrupted. And this happened because there's a special byte, the SQLite, every time the database crosses a gigabyte, SQLite adds a special byte to the next page that comes after the first gigabyte, and Turso did not. So by not finding the byte, the structure of the file was same, but that one page at the gigabyte marker didn't have that special 1 gigabyte marker, which we didn't really know was a thing. And then SQLite would fail the integrity check. And the reason we had that is that we were so aggressive by injecting faults that none of our databases actually got to a gigabyte because they would fail before that. Like the simulator would inject failures and stop so you would start adding data, and then the simulator comes and crashes you and like simulates a crash. So in none of our runs that it ran for long enough to get to that point. So we started having specialized versions of our test suite. So for example, there are entire runs in which we just check properties without any fault injection, because that allows the database to run longer. And then there's a separate run that adds fault injection. And then later we found out that the simulator was pretty hard to find issues with concurrent access. And then we wrote in another simulator that only stresses concurrent access, right? So today, Turso is tested with the Turso deterministic simulation testing. Turso is tested with a concurrent tester. Turso is tested with differential testing, in which we randomly generate queries, compare the result to SQLite and Turso will give, and see if they're the same. We also use antithesis, which is a very interesting tool, which is a deterministic hypervisor. So in the deterministic hypervisor, you can because it sits at the layer below, you can put any software there, and they are a lot more aggressive in finding issues. So whatever bugs escape our simulator, antithesis usually finds. And then we have carnage mode, which is a special run of antithesis that runs for 2 days in a row during the weekend. So every weekend we run carnage mode, and that is like trying to obliterate the database to oblivion. And it finds a bunch of bugs. And now we are adding formal methods to the test suite, right? So, and by the way, that there is this guy, we actually brought him in as an intern. He came from an open source community, lives in Bangalore, and using formal methods, he found 10 bugs in SQLite itself. So what he did is that he used formal methods to verify Turso, but then just so he could figure out if the model was correct or not, he said, let me run against SQLite as a test run. And then the model disagreed with SQLite. I mean, and as we started investigating, those bugs were reported to SQLite and fixed. So there were, that was Pavan Nambi. He's not on Axolotl, he's on our GitHub community a lot. So again, we test Turso, man. We this thing about like those guys are not going to build a reliable system because only SQLite can be a reliable system is just not true. It is correct that we're not going to have the time and the capital to invest in a 10-year run of writing 6 times more lines of code than Turso. But the truth of the matter is that the testing and the reliability community evolved tremendously in the past 10 years. And there are a lot of those techniques that we can use, and we do use them. So again, between formal methods and antithesis, carnage mode.
Could you talk a little about what is antithesis? It sounds like it's a company, but it's also like a testing method. So just could you go into that?
Antithesis is a company, very expensive product, worth it. But antithesis is essentially deterministic simulation testing on steroids. If we can, I'll put it in very simple terms, and because they sit underneath the database, underneath the system, the hypervisor itself, which is the thing that schedules virtual machines, is deterministic. So everything you do in that system is deterministic, and they inject a tremendous amount of faults. They can find bugs that our simulator cannot find. They can find bugs in our simulator. They can find bugs in like.
This brings me back. Actually, I see a blog post right here: finding bugs in Raft implementations.
Yes, they find bug. If the bug is there, they'll find it. And the thing is that antithesis can be tuned. It run for longer, and then it's way more expensive. It uses a lot more resources, but it finds more bugs. Or you can run just for a couple of hours, and then you find some bugs, but you don't find a lot of bugs. Because the more it runs, the more it stresses things and the more it explores. So our carnage mode is essentially a weekend run of antithesis with like all faults that we can possibly inject. And it finds a lot of bugs. It finds a lot of bugs. So, and in fact, again, it also found the bug in SQLite. We were running something, and I posted about it on X the other day about how our carnage mode found the bug in SQLite. That's essentially that. So we get a rough estimate of how much cost? Hundreds of thousands of dollars for the most basic things. It's quite expensive. Totally worth it. My best vendor. Because they find all the bugs, man. Now, the reason we started adding formal methods is that exactly because antithesis is very expensive. So formal methods are much harder to do, but they catch the bugs a lot. They catch the bugs a lot earlier because you don't need to run anything in formal methods. I mean, it's a mathematical thing, right?
Yeah, I was gonna say we get really defined formal methods, but it's basically like using a math proof to try and find a bug, essentially.
Essentially, right? So if the bug is found at that level,
do you have a guitar under you?
A guitar? No, this is just my microphone because I was just sipping some tea. So formal methods are amazing, and if a bug is found at that level, it's much cheaper. It's just way cheaper than letting antithesis find it, right? So we want, and again, we also do integration tests. We also do unit tests. We do all sorts of things, and they all serve a purpose in the Turso testing world. But man, everything has bugs. SQLite has bugs. Turso has bugs. Everything has bugs. But we are very confident in our ability to find them. And between how does one define a formal method? I'm not familiar. So formal methods essentially have a mathematical model of your software. And then essentially you can prove mathematically that it either works or it doesn't.
Yeah, I'll go back to my AI overview. Formal methods are mathematically rigorous techniques used to specify, develop, and verify software and hardware systems. You have formal verification, formal specification, and automated synthesis. That's
pretty much what it is. Yeah, we also have a partner that helps us with formal methods called areta.ai. So aretta.ai. And what their companies, formal methods are incredibly hard to do, very bespoke, because again, it's essentially it's very hard to generalize them because it's essentially a proof of that system. So Areta is trying to use AI to make formal methods a little bit more approachable, and it's been working fairly well for us.
I really like your guys' blog post, by the way. You write a lot of really great technical blog posts, so big ups for that.
It's just it's what we're doing, and then we post about it. But look, everything we do in Turso is done with the idea that we want to build the most reliable database that we can. We consider reliability a feature of SQLite. And if we want to re-implement all features of SQLite, it's not done if that feature is not there, right? So we truly see reliability as a feature. We truly see it as a must-have for every system, and we take it incredibly seriously. I think the fact that our testing methodology found so many bugs in SQLite already.
And then were you able to actually upstream those bug reports in a meaningful way?
The bug reports, yes, but again, it's very hard to get your code into SQLite. We don't even try. Yeah. But we reported those bugs, and to the best of my knowledge, some, if not all, were fixed fairly fast. And so again, Richard Hipp is a tremendous, monstrous individual.
Yeah, no, very, very interesting fellow. Dev, what do you know about all this type of testing? Have you ever used any of this stuff?
Not much. So I have been recently exploring more like different kinds of testing because of my project Spectre, which is essentially a way to define some sort of structured specifications up front and have AI generate like the implementation and like kind of have some deterministic verification of the AI generated code. So I have been looking a lot at like what are some different and like different levels of kind of testing that you can perform. And one of them that I kind of ran into was something was similar to what, actually a couple of them. So like one was kind of trying to take some test scenarios and generate a lot more test scenarios to kind of explore a wide variety of kind of like inputs and outputs and like basically problem spaces that you might not have declared upfront. Another one was like Glauber was mentioning, like what if every single dependency of the code that's being tested was somehow mocked, or you gave it, so even random, if you run it twice, it'll give you the same result because you gave it the same seed. So and then like a lot of other ways. So yeah, it seems like there's like a bunch of different layers. It's kind of like a cake. Like I would always go ahead.
I was gonna say, I just want to step back and ask a super duper noob question. So when it comes to these type of testing methods, are you still testing like happy paths versus edge cases?
We do, because we do, and the reason we do it is exactly because every single one of those testing methodologies have a completely different cost performance curve. So when you have, like, again, we do use a lot of AI to code. We still review all of the code, and we don't believe we should stop. Perhaps one day, but I think, again, and this is not a general statement, because people love to make general statements, right? But the reality is that every class of problems is very different, and you have to make the choice. Like, I don't test our dashboard, man, the same way we test Turso. And sure, we use AI. We don't read necessarily, we read through, we skim, and remember, I don't actually have a front-end developer because we, as I said, we kind of got rid of them all when we started, and we did not. This is the time in which we kind of had to hire them back, and soon we will. But we kind of say, hey, look, I mean, we're going to start making improvements to our dashboard because it was really quite bad, and this was just the price that we're okay paying for allowing ourselves the time and the runway to rewrite SQLite. But you know, what business do I have reading React code? I'm not going to understand it anyway. And like, what's the worst that can happen? So
famous last words.
Yeah, you know, so it does happen that sometimes I push some code and then like it's wrong and somebody complains that it doesn't load on mobile. You know, but you know, it's very different than HR data in a database.
Hey, you might have a use effect DDoS your own service.
Yeah.
But then again, it happened to Cloudflare when people were still reading the code. So
not to discount it, right? But different domains have different requirements, and then we use a lot of AI to write versions of the code, or again we read it, and the way we've been doing is that most of us, we go in a loop in which we're still fairly in the loop. We write code, and then we read the code, and then we tell the agent, change this, change that, rewrite this, refactor that. Feels like reading patches in the Linux kernel, to be honest. Yeah, I mean, the Christmas theme is the clear example of the kind of stuff that we don't have the bandwidth to do while we were writing SQLite. It was super cool, though. I mean, I agree with you. Maybe I should try to see if Claude Code can come up with a Christmas theme. But
that's actually, I was just about to ask that, whether you guys are Claude Code, Codex, what kind of models you're all using.
I use Claude Code, but we don't mandate have people use. I actually use both, but I like to use Claude Code, then Codex, and then one reviews the code that the other wrote.
I do that too. Yeah.
So this is a technique that seems to work pretty well. Although a lot of this is, quite frankly, just black magic. I mean, nobody knows if it really works or not, but it feels like it works, so we'll do it. And you don't run Carnage mode in the loop of the AI agent, because Carnage mode takes a weekend, right? So it's you run the unit tests, and the even like antithesis for us is a daily thing. We run antithesis every night, for a certain amount of time. You don't put this in. So everything like formal methods are it's a completely different thing. Like it's its own thing. And we send it to the system, and sometimes something pops back. I mean, it's a completely asynchronous thing from our point of view. Antithesis, Carnage mode, and our DST are, the DST is a lot faster. So antithesis, Carnage mode, there are like post-commit things. We'll run it every day or every weekend. The DST we run when we are about to commit. So we're about to commit something like we've been developing for a day or two. Now it's time to run the simulator, and then it will find bugs. But during that loop with the agent, right, the best thing is happy paths and adversarial examples.
Yeah.
Because those are very easy to run, right? And you use the agent itself to generate them, so it's fine. And the big problem with that is that you end up having to have a lot of tests to cover a meaningful part of the space. But again, this is not a problem anymore because it's so cheap to generate them. So we do have like a lot of unit tests and a lot of integration tests, and they're there forever, right? Once the feature is done, they're always going to be there. But they serve it at they're still the best guardrails for the agent because they're very fast to run, right?
And then did you answer this question? How do you categorize severity of each issue?
Oh, they're all severe. If there is a bug, like databases shouldn't have bugs.
Yeah, anything that can come. I was trying to find some information about Carnage mode. I couldn't find it. So
no, this is our own nomenclature.
It's like an internal thing.
Yeah, Carnage mode is just like saying, now I have the whole weekend, man. We can unleash all resources on that, and let's bring mayhem. It's not established.
Search it now; they're gonna find this stream. So
I think maybe Netflix Chaos Monkey might be like a similar-ish reference point.
Well, similar, but the thing about the Chaos Monkey is that it's always running. Like for us, Carnage mode is a flip. Like now we're gonna go Carnage mode, like run the whole weekend and find a bunch of stuff.
Yeah. I think to put the testing stuff in perspective, there's like the test pyramid that most people are familiar with, where like you have unit tests at the bottom, where you're supposed to have like the most number of unit tests. They're the cheapest, fastest to run, and they test like individual things. Then you have integration tests, and then you have the end-to-end tests. So those are like the three layers with, like you were saying before, different cost to performance kind of ratio. Like they're testing different things. You still want all of them. They all kind of catch different things.
And because of that, you kind of have to run them at different parts of the process.
Right.
That's the whole thing. Like, but we never release a version of Turso that do not pass.
Of course,
the whole thing, right?
Yeah. So I think what I was saying earlier is that I'd like to see a sort of a diagram like that for all the kinds of testing that you guys do. I think you probably have a blog post where you describe, or you probably have.
We don't. I think somebody on X the other day said that we should write a blog post with the whole thing, because we've written about all this, but scattered around, right? So here's how we do this, here's how we do that, and it's not a bad idea. It's just that I haven't had the time to do it.
So what's the compute cost?
No, it's not that much. It's fairly expensive. It's just it's not 100K compute per weekend. What I said, it was a couple of 100,000, and so it's not just 100,000, many 100,000. But that is our yearly spend with antithesis.
How many RPS does Turso make as of now?
Requests per second? I don't know. It depends. Yeah, but I do know that this person asked about PG Micro, and we went into the testing. So let me talk. Let me talk about that now. And the one day I am talking to the CTO of a relatively big company, and he's been asking me why can't we just do what you guys are doing for Postgres? And then he even say, I vibe coded let me just pause here, because still, with so many issues, how do you have the bandwidth to make the number of decisions and how to handle different Carnage mode issues? Again, there's not that many issues. That's also the thing, right? So just after all of this, there's not that many issues. So it's fair, because I said this thing, which it's a great soundbite. We don't, everything's a priority because database should have no bugs, which is true. But by the time we get to that weekly run, we caught a lot already, right? So the goal.
Yeah, I mean, it's a similar thing with the testing pyramid. Like if most of your bugs are caught in the end-to-end phase, and that probably means you don't have good unit tests.
Exactly. Yeah. And so it does find issues, right? So it's not that it never finds anything. I mean, and closer to the release dates, it finds hopefully fewer and fewer, but not always. Sometimes you put some stuff at the late in the game, and then it finds a bunch of issues. But it's not that many. It's not that many. But when we do find them, it does mean that it escaped all layers. So it's probably we don't really prioritize what we see there. We just whatever it needs to be fixed. On the other hand, it is very rare. Again, it does happen because remember, none of this is magic, right? You have to write the simulators, you have to write the test generators, you have. It does happen, but it's usually not the case that there is a bug that this testing methodology finds that is in a released version of Turso. So it's usually in the next release. So on the other, we also have the ability to just say, if it takes too long to fix them, we just delay the release, right? Prioritization works when you have a deadline and you say, hey, we have to release by that date. I can give an example of a unicorn company I work for. Just an example, they throw exceptions for their JavaScript up to Claude, then return the summary to the user. Interesting uses of AI. It's you have to get creative in the age of AI. I love saying the phrase "the age of AI." It makes me sound so visionary. but anyway, just I'm chatting with this guy, and he tells me, I vibe coded a translation layer that translates Postgres queries to SQLite queries, executes them on SQLite. Boom, now I have Postgres on SQLite. I said, no, you don't. And the reason you don't, and I started explaining to him, that the reason you don't is that there's a tremendous impedance mismatch between SQLite and Postgres. You're going to try to translate this to Postgres, Turso, even to Turso. Like, how do you translate the Postgres types? What you're going to try to do is you have to compress the Postgres types into SQLite types and back. You're going to have all sorts of edge cases with that. SQLite will not support materialized views. So how do you do that, right? And so you can fool yourself thinking that this worked, but it truly didn't work. But then as I started thinking about it, I had an idea. Said, hold on. I think I know a way to make it work. And the realization that underpins this, and then I run an experiment, and then I run an experiment, and the experiment did quite well. And I'll tell you in details, because I think your audience is going to appreciate that, how exactly the experiment was. But my experiment was this: instead of doing this translation layer and like translating queries, like get a yeah. So we'll get to Shreya's question, but instead of getting the queries, Postgres query, translate to a SQLite query, I have a better idea. What I wanted to do was like, can I translate the Postgres queries into the AST, which is the intermediate representation, like a abstract syntax tree. So every language of any kind gets parsed to a AST, be it JavaScript or Postgres or SQLite. And once I have the AST, it doesn't truly matter if it's Postgres or SQLite anymore. I mean, everything that was special about Postgres is lost at the AST layer. The AST is really truly an intermediate representation, right? The AST has things like join, table A, table B, select as a tree. And a lot of people do not know. A lot of people do not know that SQLite is a very special database. I do not know that, to be just to understand. I'm not saying it's very widespread that some people may not know. Like when we started working with SQLite, like the Chisel Strike days, I did not know that. But SQLite is a VM. SQLite is a bytecode VM. So SQLite, what it does is that it has the SQLite dialect, and it compiles the SQLite dialect to a VM, like the JVM or .NET or JavaScript, V8, right? So all SQLite is doing is compiling the language to a AST and then running, and then you have another step that compiles that AST to this VM, and then it executes the code in the VM. And in V8, you're going to find things like load an integer, copy a string, things like that. And in the SQLite VM, you're going to find things like open a B tree, transverse a B tree, create an index, but still a bytecode language, right? At the end of the day, is just that. So my thinking with PG Micro was, how can I compile the Postgres language to the SQLite bytecode? And if I find a mismatch, can I then improve the bytecode and at that point do the translation? Because if I can do that, then there's no impedance mismatch. If there's anything that the SQLite bytecode doesn't do, I'll just expand it. And the first, so I run a prototype. So let me do like the most basic stuff. And the first big thing was exactly types. So again, SQLite doesn't have types. SQLite is just, as they call it, the JavaScript of databases. You create a table and you say this column is an integer, and then you write the string Anthony. Congratulations, Anthony is now an integer. And it is the way it works. So what I did is that I added types to Turso. So Turso has now experimental supports to types. And if you go look at the date that I added that was the date that we kind of decided, if this works, we're going to go write Postgres. Now it takes time, right? Because the reason this is not incredibly crazy is that we're not starting from scratch. Again, we're starting from a working database, a database that's tested to the smithereens like crazy, and already has, it can already do select, inserts, updates, indexes, all of that. And all I'm doing is translating this to the bytecode. And then the hard part is when you find the impedance, when you find the stuff that SQLite doesn't do, then we have to extend. So we added experimental supports to Turso. It is not production ready yet. It will be. But the goal that we had was exactly like, if this works, we can rewrite Postgres using this. And this is incredibly powerful. And this was the PG Micro experiment. Again, I think it worked tremendously well. And then we merged it to Turso. Yeah, so now PG Micro is not a thing anymore. All of that code was merged to Turso. So now Turso supports Postgres. Now, it supports Postgres as well as we supported SQLite a year ago.
So, here's the historical. Yeah. This was.
I have to go update the README, by the way. I keep forgetting, but I have to go update the README saying, hey, this is now part of Turso in case people find it. But we support Postgres the same way we supported SQLite a year ago, which means like we support like 30% of it, 40 perhaps. Against Postgres is much larger than SQLite. But our idea is that, look, if we can do this, first of all, we can have a much more modern version of SQLite that doesn't have like process for connection. We can really re-architect the thing. We can have a version of Postgres that runs natively in the browser. We can have a version of Postgres that runs embedded on devices and runs it as a file, that runs it in memory, that does, because the same way I'm expanding SQLite with the good things of Postgres as I do this, it goes in the other direction too. And Turso, the cloud, the thing that started defining us, especially with AI, is that it is truly we have customers on the Turso cloud today. They're deploying more than 1 million databases, like a single customer. And with agents, it became a thing. Like we had before, if you've talked about like, hey, somebody deployed 1 million databases, you go, why? Now it's because you have those agents coming online all the time, and like the agent decides to create a database, they create a database. There's nothing that prevents them from doing this. So with agents, the idea of a database per agent became very attractive, and the idea is by supporting Postgres, we're going to be able to offer a version of Postgres that you can deploy by the billions as well, right? So that's essentially in a nutshell what that is. Do they have enough UIDs? They do. Like you need more than a couple million to exhaust the number of UIDs. But again, the goal there is that everything that we're going to do is going to inherit the reliability of Turso. So we want to write this in the open like we did Turso. So everybody's welcome to come and contribute. We have almost 300 contributors at the moment, and we were hoping to get even more. But the goal is that you would have a database. By the way, we just don't talk about it, but somebody put MySQL support already, because it's not that hard. MySQL is actually simpler than Postgres. It's somewhere in the middle. Why not? We as a company, we're not going to invest on it. But if somebody comes in the open source community and wants to improve MySQL support, by all means. Redis was floated as well. I think that Redis is a great thing for us to do. And there are a couple of bytecode instructions we will have to add to support Redis, but it's 2 or 3. And now the most interesting part: how do you know if a VM is powerful enough and general purpose enough to support any workload? And the way you prove this is you run Doom. So I ported Doom to Turso. And because Turso runs in the browser, you have a Turso database embedded in the browser running the game Doom. And essentially the render loop of the game is a select query. So there is a select query that yields. So the select query, it's a select query that generates infinite amount of rows. And every time it yields, that's a frame of the game. And then you keep playing the game, right? And do you have that on GitHub? I do. And if we can do screen sharing, I think Anthony should go play Doom. And the goal there is that like
Dev's never played it.
The memory, and no bytecode instruction, no extra bytecode instructions were needed to play the game. In Turso, like, because we did use some instructions that SQLite doesn't have.
We got the blog
right there. You go.
Here. How do I get to the actual game?
It's right there.
Oh, there. Okay.
You press ask and enter to start, arrows to move, control to fire, space to use an item. You select the window, and then ask and enter.
Oh, escape then enter.
Yeah, escape. Yeah.
And then okay, I think I'm in there now. So enter to start. Which episode? Okay. We'll go easy mode now. No, there we go.
So this is every frame is a select query, and then we filter the results of the select query, get the input that you did,
control to fire. There we go. All right, let's fucking go. Wow, this is dope.
Yeah, and then I wrote a C to SQLite VDB compiler. VDB is the bytecode instruction, and Turso.
So remember where the armor is.
Yeah.
So is every interaction like an update query?
Yeah,
and every frame
it updates a blob. So the memory is a blob in a table, right. And it's like chunks of 64 bytes, 64 kilobytes, and then you chunk it, and you have those blobs. This is running in database code.
Yeah,
and again, the render is a select query.
You can feel there's a slight amount of lag, but it feels pretty responsive.
Yeah,
for the most part. Like I'm able to play it like it's a real game, which is just absolutely incredible.
If someone on YouTube is asking, wait, you're actually playing a game? And yes, this is Doom running in Turso, running inside the browser, which is it's running in WASM.
Yes, Turso compiles natively to WASM, and then man, your ammo's doing. And by the way, that's what I write in the blog. If you want to keep playing, you're just reading a technical blog and studying. This is work time for you. Okay, it's all good.
That's true. Yeah, that's
Right,
really cool.
We're on the clock. This is doing research for the company. That's amazing. Okay, so
if you can run Doom, you can run Postgres. That's what we say, right?
Actually playing.
Right. So Turso, the database, it's the same database that your customers have been using for a while, but that same database can now accept queries that are in Postgres as dialect, because in between you have a compiler layer that can compile Postgres dialect queries into an AST that Turso understands, which is also the same thing that it's doing.
That's a parser, really, right? It's not the entire compiler, but like that's what Postgres would do. Like that's what any database would do. Like the database gets the query, compiles it to AST, and then do something with that. And the only difference is that we just compile Postgres to the same AST that we're already using for SQLite. So when at that point the AST is already the AST to bytecode is already hooked up, right? So at some point, very early in the process, even the database doesn't even know if it's running SQLite or Postgres. It's just running the bytecode, and there's the same bytecode that just run Doom, but running Postgres, running SQLite, running it could be anything.
So that's where the LLVM analogy comes in.
That's right.
As in, like, the front end of the database is different.
That's right.
Just like with an LLVM compiler, you can have a different front end, but the compiler
and the analogy breaks because, again, you're right. I mean, we started framing Turso, and I think it was very well received by internet standards. So the amount of hate was around like 5%, which is great.
Did you post it on Hacker News yet?
Oh, of course. I mean, and again, 5% is a great result. It means people really love it, and the idea of a LLVM of databases resonated fairly well. And that's exactly that. If you're not familiar with LLVM, the compiler, before LLVM, you have like a C compiler that has C and then all the architectures. And then you had the C++ compiler for all the backend architectures. And then you had whatever. And what LLVM did is like, we're going to be a intermediate representation layer. And then you can just write front ends. You're going to have the C front end, the Java front end. Again, you can. There are compiled versions of Java, and they tried to do this in the LLVM project. Then Rust came later, and it became. By the way, the database that I like the most is not even SQLite and Postgres written in our bytecode. The database I'm excited the most is whatever you're going to write in the future.
So the database is the friends we made along the way.
Because like if you think about Rust and Zig, etc., it's not that they would not have existed without LLVM, but LLVM made the act of creating a programming language so much easier. Because now, again, you didn't have to write all that stuff. You could write just the front end, and everything else was already there for you because it was the same infrastructure. So that is exactly what we're trying to do. Our idea is like if by turning Turso into the LLVM of databases, SQLite was fairly hard. Postgres will still be fairly hard. But after those two are done, quite honestly, if you want to come and create like your crazy experimental database, it's going to be super simple. So why not go nuts? So I'm very excited. The same way that Rust was way more interesting than all the languages that LLVM supported in the beginning, right? I think I would have to. That's what I want to see.
Okay, I want to just make sure
So
we're
when you
hitting
say
all these questions before we go to the next thing, what are your thoughts on PG Lite?
Again, PG Lite is great. I think it shows I'm good friends with the creator. It shows that the demand for running Postgres in a file is tremendous, but it's not the right architecture. It's not the right architecture because it's super hard to do. Like you have to leave a lot of things in the table. Like WASM doesn't support threads. Postgres is incredibly threaded. In fact, it's more than threaded. It's process based. So it has limited applicability. A lot of the things that people say that our implementation won't be able to do, they can't do either, which, for example, like loading arbitrary Postgres extensions. So at the end of the day, I think they have more limitations in a sense than what we're going to come up with. And our performance is going to be a lot better. So this is, in some sense, PGLite reminds me of the fork of SQLite. I mean, the right idea, but not enough ambition. And I think what we're doing here is the right amount of ambition.
What was your question, Dev, that you had?
Yeah, I was just saying, so like when you were saying that you can write your own database, like technically speaking, you would be writing a front end, like the query language or the interface of how you want people to use the database. And then instead of building the entire database itself, I just need to write the parser layer from my custom query language to Turso's AST.
That's right.
Okay. So I guess what does Turso's AST look like, and how different exactly is it from like SQL? Like what's a general idea of what makes up the Turso AST? Like how do you what does the backend look like?
So again, an AST is just a tree of statements, and then you're going to have it's essentially a superset of relational algebra, right? You're going to have joins, selects, and then inside the select you have the parameters. If you think about how would you express a SQL or any SQL query in JSON, you're going to end up with something very similar to what the AST is, right? It's a structured tree-like amount of elements. So you're going to have a table. Then you nest another table in there, and then you have attributes to that table, and you create a structure. That's the AST.
Right. So
again, the name AST means abstract syntax tree. So the whole point is like to try to get the thing that is your language and transform that to a representation of that is abstract. So it doesn't have the details. It doesn't have the syntactical things, but all the elements are represented in the AST, the attributes, the nodes. Each node is the operation, and then in each operation you have the attributes, like which table, which columns, and all of that, right?
Right, yeah. And kind of going off of Shreyas' point here, that you can go farther than just a SQL-like thing. So I guess, in that kind of vein,
you can.
If I try to imagine a database that's very, very different from what SQL looks like. Like the relational algebra. Like how much work would that be to implement? Like, are there things within Turso?
No, it's not. It's not a lot of work. In fact, as I said, one thing that would be super cool would be Redis, and from my understanding, which could have gaps because I'm a person and. The only bytecode instruction you will need to add is something to deal with TTLs. Because Redis has TTLs, SQLite doesn't have TTLs, also Postgres, my understanding is that it doesn't have Redis-style TTLs at least. So you would have to add a bytecode to handle that. Once that's in, it's all like translating the Redis language to opening files, closing files, finding something in a file, all of that.
Awesome. We could probably start winding it down here. We almost made it to 2 hours. We had an awesome group in the chat today. Really appreciate everyone being here, asking questions. Last things you want to end us with, Glauber, where Turso's going, what you're working on now, any calls to action?
Yeah, so Turso is, we just announced concurrent writes on the cloud, which is, as some of you were remarking, some of you are receiving the email right now, but I started the newsletter around 4 hours ago. So we announced the concurrent writes in the cloud, which nothing more. At the end of the day, it's just like Turso is finally being executed on the cloud. Our cloud was still running SQLite up until today. We've been running this in private beta for a while, and now it's public. You still have to flip a switch because it's a production thing, so we want time for people to report issues and the kind of issues that you don't find at the private beta because you don't have scale. So I would like to. We're gonna run. This is. We're not going to default to Turso, and you're going to have to flip a switch saying that you are aware of the consequences of your actions for a couple of months. So we don't expect this to pick up tremendously. But some people are, I see in the Slack channel, the people who are enabling this already, and it's been going great. I mean, a lot of people truly want concurrent writes in the cloud. So Turso is going great. We're going to keep doubling down on making our cloud even better. We're going to keep doubling down, making our cloud more accessible, cheaper, faster. Again, unlimited databases. There are a lot more ideas that we have to make it even more like incredibly developer friendly, which has been the core of our brand since the beginning. And look, the Postgres thing is not a year-long project. Is something that we believe we can tackle in perhaps 6 months. So in 6 months, we can come back here and talk about like how we have.
We'll pay you to run the database. Cheaper
there you
and
go.
free.
Many things are cheaper than free, Shreyas, because free comes with a lot of problems, man. Free is always like our free tier is severely overcommitted, so queries are not that fast. Right? It's free is best. Yeah.
Amazing.
But our free tier is awesome. People love it, and we're gonna. We can do it because the Turso Cloud is so efficient.
Well, thank you so much, Glauber, for being here. This is an awesome discussion. We hit many different topics. So, and again, thank you everyone for being out here. Dev, we don't have anything lined up for next week, so maybe just you and I. But I got all sorts of stuff we can show. We can show my new drum app. That'll be fun.
Definitely, yeah.
All right.
Eric, I don't know if you're still watching, but you should come on the stream. Hopefully SQL D will never.
Yeah, SQL D is the first version, like on Leap SQL. We're gonna keep there, but our investments are modern investments are all on Turso, of course, in the infrastructure. All right.
We'll wrap it up here. We'll catch you all.
See you all.
Time.
It was a pleasure.
Thank you very much.